in 2, 1. What are we trying to find here? Ramel.
Well, how many games will it cost to both be the same?
Okay, so how many games until it will be the same price? What information do we have in this problem? Trevan.
We know that at Bolorama it's $2.50 per game plus $2 per shoes, and at Bowling Pin it's $2 per game and $4 per shoe.
What is unknown here? Timothy?
How many games? Yeah.
Okay, how many games is unknown, right? What else is unknown here? Sally?
The breaking something. The thing that the cost that the cost.
You're on the right track, Sally. Starling, expand.
I know you still talking about the break even and the total.
So our total cost is what is also unknown. How can we represent these unknowns? Write it in our first key point down at the bottom. Krista, what did you write as your first key point?
Define the unknown.
Define the what?
Unknown.
What's another way of saying the unknowns? You can say it. Go ahead.
Variables.
Good. We need to define our variables. What are our variables here? Alexia. X and Y. So what is X and what is Y?
Oh, the X is $2.50 per game. And wait, no.
What could X represent? Think about our two unknowns again. We have our cost and our number of games.
Oh.
You want to try again? Alexia, go ahead.
X is the cost.
Teammates. Why do you disagree, Joseph?
X has to be the number of games.
Why?
Because if you make the equation, it would be the coefficient.
Hold on, we don't want to make equations yet.
Oh, sorry.
But how do we know the difference between our independent and our dependent variables? Yes.
X is dependent and the game, the cost is dependent on the amount of games.
Yeah, because depending on how many games we play will depend on the cost. So our X is our number of games. And our Y is our total cost. So what can we create now to represent this information? 2 people now. 3. What could we create now? Starlene?
A system of equations.
Oh, a system of equations. So on your whiteboard right now, I'd like you to create the 2 equations we can use to represent this information. Hold up your boards on 3. 1, 2, 3, shove. Track Aisha's board. Boards down, track Aisha. Aisha, what are your 2 equations for each one?
My first one is Y equals 2.50 X plus 2.
And what bowling company does that represent?
The Bolorama.
Okay, so for Bolorama, you had Y equals, say it again,
250 X
plus 2 teammates. Good, I saw some very similar things in your board. Then if we have bowling pins, what would your equation to represent the information for bowling pins? Aisha, go ahead.
Y equals 2X plus 4.
Y equals 2x plus 4. So if we're looking at these 2 equations, what must be true? I'll say it one more time. If we're looking at these 2 equations, what must be true? Turn and talk with your partner. 30 seconds left. Spark one more time.
The y variable has to be the same because that's the total cost.
That's our total cost. So we're looking for our what here, Joseph?
Wait, oh, the number of games.
The number of games, which is also considered our what? Our input or our output? We're looking for our input, right? But in order to do that, what must be the same? What else must be the same? Our output. So under our y, we use systems of equations to determine where the outputs are the same. This is why we use a system of equations. We have to find out where those inputs and those outputs are the same. On your whiteboard right now, tell me the most efficient strategy to solve the system of equation and why. Go. Most efficient strategy to solve this and why. Hold it up on 3. 1, 2, 3. Show. Track Trevan. Trevan, go ahead and read it.
Substitution is the best strategy because you can make them equal to each other. They are both self-intersecting.
What'd you do well? There.
She clearly explained why we differentiate and not just saying that it's substitution and that y equals each other.
Okay. What could you improve on? Trevan, can you read it one more time? Make sure you're listening. Your eyes are on Trevan.
Substitution is the best strategy because we can make them equal. They are both self-intersecting.
What do you think she can improve on? What is vague in her explanation? Sally?
She said that both solutions equal each other.
Not quite. What is vague about her response? Joseph?
She said they and them.
She said they and them. What is they and them that she's talking about?
The Bolorama equation and the
Yeah, the two equations, okay? Well done, Joe, for your explanation, Trevan. So we're going to use substitution. We can use substitution, so what would that look like? What would I do now? Manithya?
Equals 2x plus 4.
2.5 plus 2.5x plus 2 is equal to 2x plus 4. Great, go ahead and solve it on your whiteboard. 1, 2, 3, show. Just show what you have so far, even if you are not finished. Track Ramel, boards down. Leave your board on your desk. Track Ramel. Hold it up, Ramel. What did your solution say, Ramel?
412.
What does that mean in context of this problem? We need a couple more scholars. What does it mean in context of this problem? Alex, I hope you're thinking right now. Aisha,
This means in
hold on. Pencils are down. Pens are down. Your eyes are on Aisha right now. Rachel, get there.
That it would take 4 games for them to both have a total of 12 hours.
Oh, so does that answer our question, 412? What does answer our question here? Abuse 2.
It's the 4 games for $12.
Yeah, they have to play a total of 4 games, right? Because it's saying for how many games will it cost the same? It will be 4 games. So after we defined our variables, we set up 2 what to solve for this? We set up 2 what, Haley? Spark it, please. Yeah, we set up 2 equations, which was our second step, and then we determined the most efficient what to solve. Alexia?
Strategy.
Yeah, we figured out the most efficient strategy, and in this case it was substitution. All in order to determine where our outputs are the same. You're going to use this criteria for success to create additional equations to solve real-life word problems today. Turn to the next page. Example number 1. Read it for us, please. Kiara.
Video club and $10 membership and $3 per movie. Video club B